Every breach starts as a missed requirement, something no one thought to write down. So before you start writing your first line of code, know what your software needs to withstand an attack and not just what it needs to work. In this video, I'm going to talk about what security requirements phase are, what the phase entails, and who should be involved, some of the challenges and solutions that come up during this phase. And finally, I'll share a brainstorming exercise your team can use for future projects. Regular requirements gathering is usually where developers talk about requirements, functional requirements, what's needed to make the software work as expected. But in a secure development lifecycle, you also have to include non-functional requirements. These define what's needed for the application to maintain reliability, resiliency, recoverability. That means asking questions like, if the application encounters unexpected data or behavior, can it still function properly? Can it withstand malicious attacks? And if something goes wrong, can it recover quickly and get operations back to normal? The main goal of this phase is to document not only what the software should do, but also what it should not do. What controls, specifically security controls, need to be in place to make sure the application continues to operate securely and consistently, even when it's tested by unpredictable conditions or user behavior. Now, this might sound like a job for the security team alone, but it's not. Developers, SREs, architects, and product managers all need to be a part of this process. Security can uphold and enforce compliance, but it takes collaboration across the product team to build truly secure software. The secure software development lifecycle isn't a brand new idea, but it is newly adopted by many teams and organizations. The challenge is that it changes a process that's already familiar. And people don't love changing what's been working for years. But what makes this phase even harder is when requirements just aren't smart. And no, I'm not talking about intelligence. I'm talking about Peter Drucker's concept: specific, measurable, actionable, realistic, and timely goals. Let's apply that to security requirements. They need to be specific, which means no vague or broad statements. They need to be measurable. There has to be a clear way to test whether the security requirement has been met. They should be actionable. The developers should clearly understand what needs to be done. They should be realistic, achievable within the constraints of the project, and they should be timely, high priority when it's time to implement. When requirements meet those standards, communication between security and product teams gets a lot smoother. And everyone knows exactly what's expected, what's possible, and what success looks like. Now, once everyone's on the same page about what a smart security requirement looks like, then you can start worrying about brainstorming with this exercise I like to call Coders and Intruders. So here's how it works. You can split up into 2 teams for the dev, or you can invite the security team, dev versus security team, for even more fun. One side plays coders and the other side plays intruders. And the coders come up with use cases and the intruders try to think of ways to misuse those use cases. Then both sides come together to figure out what security requirements could be put in place to stop those misuse cases. For example, as a user of an e-commerce site, I want to register as a customer and save my credit card to the site for ease of use, convenience. Well, as an intruder, I want to exploit a weak password reset process, change the password, and then steal the stored credit card data or information. And given that example, what security requirements could prevent that? Maybe enforcing stronger password policies, using multi-factor authentication, or encrypting stored card data, just to name a few things, right? And what's that type of thinking this phase, and that's the type of thinking this phase encourages. Understanding not just how your software should be used, but how it could be abused, and preparing for both. So I hope this video helped you understand what the security requirements phase is, why it matters, who needs to be involved, and how to start building these security requirements into your own projects. Now, in the next video, we'll move on to the secure design phase. And this is basically the steps that come after defining your security requirements. So I'll see you then.